Hi, I'm Elvira Nurgalieva with Calibry International, and today I'm going to show you how Calibry can be used for reverse engineering. And to do so, I'm going to scan this part with Calibry and convert it into a parametric model in Geometric Design X.
So my plan is, firstly, scan each side of the part and process them into a 3D mesh. Secondly, merge them in one 3D mesh. And thirdly, import the 3D mesh result into Geometric Design X and turn it into a CAD model.
First of all, as you can see, this part sort of a cylindrical shape. I need to apply an additional geometry. In my case, I'm gonna use crumpled paper.
Here I'm scanning one side of the part on a turntable. It's just more for my convenience because I don't have to walk around it and just can stay at one place. And now I'm flipping it over to scan the other side of the part. And this is a 3D result of scanning. Nice and clean. This is the 3D result of the other side.
It turned out that two scans I made, both of them are missing this part. So I'm gonna rescan this part, but this time I'm gonna using targets. Targets are also great for scanning the objects with the shape which is like this, a cylindrical shape. It's actually not enough geometry.
I've post-processed the data and I'm showing only the mesh result of the inner part. Looks good enough to go to the next stage, where I'm going to align this scan with the other two scans to make a complete mesh of the disk. I've merged all the three scans in one, and here I'm demonstrating the final mesh. We can see all the surfaces of the part, and now I can save it in STL format. And the STL format I can import into Geometric Design X for further transformation into a CAD model. Now when I have my mesh data, I can convert it into a CAD model. Most CAD systems simply don't have tools to manipulate with mesh data. Geometric Design X provides the solution to turn mesh data into a CAD model, which then could be imported into a downstream software. To begin with, I'm going to Home tab, and on the left I'm hitting Import button to import my STL model into Geometric Design X. In the same Home tab, I'm selecting Auto Segmenting button for the software to identify segments of the part based on curvature. I'm going ahead and hitting the Accept button. It takes a few seconds to complete the command, and we can see the progress at the bottom of the screen. Now different colors highlight different regions. As you can see, base planes are all misaligned. And I need to align them in the way so that I can use base planes for creating sketches. I'm planning to have one of the base planes at the bottom of the pot. And all I need is to hit plane button, select this plane region recognized by the software. I feel okay with it and I'm accepting the command. I've got a plane, but I also need a vector to align base planes with my pot. So I'm gonna create a vector which is gonna be a center axis of this disk. And this is why I'm going over to the Model tab and hitting the Vector button. I'm selecting Revolution region as the entity, and now I'm noticing that there is also the plane there, which was selected in the previous command. I don't need this plane for this command, and I'm removing selected entities in this menu and reselecting Revolution region. In the Method drop-down menu, I'm selecting Revolving Axis. Checking out the preview of the vector, which is highlighted in yellow, looks good to me, and I'm accepting the result of the command. Now it's time to align this spot with the plane in vector which I just found. And this is why I'm going over to the Home tab and hitting Interactive Alignment button. For the plane, I select plane 1. For the vector, I select vector 1. Here I'm checking out how DesignX aligned the part with the base planes. Looks okay to me, and I'm accepting the result of the alignment. Now I don't need plane 1 and vector 1 anymore, and I'm deleting them. These base planes will help me to cut this mesh apart in the way so that I can see inside of this spot and extract my reference sketch. But I still need to find an axis which is an intersection of the two top and right base planes, because this axis is going to be a reference axis for the revolving part. I'm going over to the Model tab and hitting the Vector button. In the Entities menu, I am selecting the top reference plane, then as the method. In the drop-down menu, I'm selecting Intersect two planes. Then I'm selecting the second plane, which is the right plane. The first one I've already selected. And I'm hitting OK button. Now I'm gonna go over the Sketch tab and start making base sketch by hitting Mesh Sketch button. I'm selecting Rotational Method and I'm choosing Vector 1, which I just created, and the right base plane. So the idea is to create a sketch, then just use the tool which allows to revolve the sketch around Vector 1. And that will create a round shaped part, and that is exactly what I need. In the next step, I'm selecting Silhouette Range 15 degrees because the part's got holes inside it and I need to collect information not just from one plane but from a larger section of the part. So I think 15 degrees will be enough, and I can do that just by dragging the arrow. Now I can hit OK button. I created a reference sketch. Now I can switch off the mesh so that I can clearly see the sketch. There are multiple lines in the sketch. And you might ask a question, why are there so many lines in here? And I'll go back to the Sketch tool and explain multiple lines in the sketch. Here you can see inside the silhouette, which is 15 degrees off each side of the right base plane. There are at least 3 planes, and each of them cutting the part, and each of the planes creating its own sketch. So at least 3 sketches are in one silhouette, each of them, all those lines in here. In fact, all those lines show how imperfect and not really round the real part is. Because if this part was really perfect, we would see one line for inner and outer surface of the part. These pink lines are still part of the mesh, and it is just a template for creating a sketch, which is going to be a base for a parametric model. And I can do that by hitting the Auto Sketch tool. I'm selecting Make All Curves, and we can see the result of the command in blue lines. Accept changes. Now these blue lines I can edit, and the final result is going to be a parametric model. So as you can see, Geomagic provides a powerful tool to convert the mesh into a parametric model, but it doesn't happen fully automatically. You still need to draw lines or remove them. And all this depends on your needs and how accurate the final model you want to have. I need to mention about very important rule about building solid models. There must be always one line for one surface, because this is the only way to keep integrity of the solid model. If there are more than one line for one surface, Geomagic won't be able to build a solid model. Also, while drawing all those lines, I need to maintain the continuity of the lines and curves. They must be not duplicated or disjoint. That is one of the main conditions to build a solid, watertight model. Now I need to explain what this element is. This is the valve, and we can see it in the mesh here. I made a sketch with a 15-degree silhouette range, and in this range this valve got captured as well. But for simplicity of the CAD modeling, I'm not going to draw this valve. And I'm going back to my sketch. Geomagic drew a lot of lines, in fact too many. Some of them are redundant. I have to delete redundant ones, and I'm using the trim button. In the menu of the command, I'm selecting Power Trim and gonna select the lines which are duplicated or obviously not correct ones. So my goal is to try to pick sort of an average line amongst those multiple lines. I'm removing all those curves, and then later I will be replacing them with more straight lines. I need to delete all these duplicate lines as well, as they will interfere with building the solid model. Here is too many lines. I'm going to delete most of them just to make sure that no duplicated lines left. Then after I finish this command, I'll draw new lines. And while I'm deleting these redundant lines, I want to explain what these points are. These points are centers of the arc of circles created by DesignX, and I don't need to delete them. Now I hope you've got a good grasp of how editing the sketch happens and what tools could be used for that. And I'm speeding up the editing part of the video until I've finished with editing. Now I'm done with editing and I'm zooming out to see if there are any disjoint ends left. Okay, there are no disjoint ends, and now I can exit the command. Now the sketch is ready for the next stage, which is creating a solid model. And I'm going to revolve the sketch around the center axis of the model. And to do that, I need to hit the Revolve tool, which is sitting in the Model tab. Revolve tool created the solid model based off the sketch which I just created. And you can see that in the Profiles menu of the command. And Vector 1 was automatically selected as the revolving axis. And that is exactly what I needed. I'm hitting OK to finish the command. Here is the solid model, and I need to extract the information from the inner side of the part. So I'm gonna go back to switching the mesh on and switching the solid model off in the model tree in the left sidebar of the screen. Now I'm having the view of the mesh again, and now I'm going to cut the part in a way so that the result sketch will include the information about holes and other structures inside of the part. For this purpose, I'm going to create a plane which is going to be a base for the next sketch, which will allow to capture the holes inside of the part. So I'm hitting plane button, and in the drop down menu of the add plane command, I'm selecting offset tool. And I'm dragging the arrow because I want my reference plane to be aligned with the end of the part. Now this new plane is the base plane for my sketch, where I'm going to draw holes. In Add Section Polyline menu, I'm selecting the offset distance for my sketch by dragging the big arrow, so that I can see the most lines possible in the sketch. Which is just about here. And then I'm going to get even more information about holes by selecting Silhouette Range by dragging the smaller arrow, so that most lines will pop up in my sketch. And you might remember that Silhouette tool is cutting the part with many planes, not just one plane, and that is why there are more lines appears in the sketch. Then I'm hitting OK button. I'm switching off the mesh to clearly see the sketch. The sketch appears to be with the rough edges. That happens because all those holes are located deep down in the part, and the part's got quite an oblong shape, which provides limited space for the light from the scanner to capture more information about the edges. That is fine, we still can sort this out with Geometric Design X tools. And you will see shortly how I will do that. So I've got two types of shapes, ovals and circles. Let's get started with elliptical or oval shape. I'm going over to the Model tab, and in the Draw group, I'm hitting Ellipse button. Here I'm selecting this curve, and the tool automatically fits ellipse into the curve. And I'm accepting the command. Now I'm creating circles by hitting Circle tool in the same Draw group. And I'm starting off from the one in the center. I'm gonna make it by clicking onto the vector, which is the center of the part. Then fitting the circle into the sketch circle with the rough edges. I still need to create 2 more circles, and I'm starting with the smaller one because I can clearly see the shape of it. The second one I'm creating by hitting into the center of the smaller one and fitting the curve, which is part of the bigger circle. Now I need to multiply the holes I've just drawn. In the pattern group, I'm selecting Circular Sketch Pattern tool. In this tool, I need to select the axis around which the circular sketch is going to be multiplied. Here I'm trying to bring the arrow to the vector 1, which is the center of the part. And obviously, it appeared to be a little bit harder than I expected. So instead, I decided to just put 0 into base X and base Y fields, because it is the center of the part with 0 X and Y coordinates. Now I'm adding 2 more circles to the same pattern. And obviously the number of instances are 3 for all types of holes in this part. And I'm hitting OK button. Now I can exit the command. So this is the sketch for the holes, which are located inside of the part. All I need is now to extrude those holes through the part using the cutting tool of the command. And I'm going over to the Model tab and hitting the Extrude button. Geomagic automatically picks the selected sketch at the previous stage as the profiles for extrusion. I'm switching on the solid model in the model tree because I need to see the lengths of the part to identify the direction and the lengths for the extrusion. Also, I'm switching on the mesh as well to see how well the command will perform. In the result operator menu of the command, I'm selecting cut because I want the extrusion to cut the holes through the part. Now I'm realizing that the profiles for the extrusion were not selected correctly, and reselecting only the profiles which should cut through the part. Now I can hit OK. Now I need to cut the final holes which are not going through the part, only to a specific region in the part. And to do that, I'm gonna select Extrusion command again. I'm selecting the last sketch as the base sketch for this command, and I'm changing the default direction for the extrusion for the opposite one, which will cut through the part. I'm deselecting the profiles which won't be part of the extrusion and leaving only those which I need. Also, I'm switching off the solid model to clearly see the mesh to identify the regions of the part. And in the direction menu of the command, method of identifying to which distance to bring the profiles is up to the region. And the region itself I'm going to select on the part itself. And I'm hitting OK button. Now I'm switching off the mesh and on the solid model to see it clearly. Here we go, nice and clean CAD model of the part. Now I can check the deviation for the body, and Geomagic provides a color map for the deviation of my created model from the mesh. Thank you for watching the video. Follow our YouTube channel for more educational and tutorial video from Calibry International.